Why is it doing this? All right. Okay. I'll give him a sec to...
Settling.
Okay, guys, so same announcements as before. If you haven't been checked in, make sure that you come up to me or Mr. Davian over there in the purple shirt to get checked in. Oh, my days. Check your kits. If you don't have anything, then we'll give you another one. And make sure that you have someone that you're working with that has that USB port on your computer, because if not, you guys won't be able to use the Arduinos. Okay, so before we get started, I want to give you guys a quick few announcements about the Explore program as a whole. So if you guys don't know, my name is Nicole. I am the Explore program manager for Init. This semester, we're doing our cohort style for Explore. You guys probably already know. We have our 4 main tracks as always, our web dev, game dev, AI, and hardware. But this time you're signing up for 2 tracks at a time. If you go to all 3 workshops for that track and you fill out the surveys that I give you, then you guys are eligible to get your little pins. We have like Explore pins for completing that particular track. So I wanted to first highlight our Explore Hub. Our Explore Hub is go.fiu.edu/Explore Hub. Here we have all of our live streams and our Notion docs for all of the workshops. So if you guys fall behind, if you miss anything, you can always go there and catch up. And then we're starting our second cohort. We opened it last week. So these are sort of the dates. We're starting with our web dev tomorrow, then we start with game dev the next week, and then AI and hardware. So essentially, all the tracks are repeating again with brand new projects. So you're able to refresh on that foundational material, but get new projects for your GitHubs, your resumes, your portfolio, all that stuff. So don't worry about the deadlines yet, because I'm going to reinforce them at all those intro workshops. Those intro workshops are going to be a chance for you guys to see if you'd like to participate in that track, if it's new to you, or if you'd like to repeat that track, if you're interested in the project that's being done. That being said, I have the cohort interest form open now for cohort 2. So if you guys are interested in repeating any of the tracks or joining any of like the other tracks that you hadn't already done, you guys can go ahead and fill this out here. I believe this is also at go.fiu.edu/initexplore if you forget. And remember, we have our socials, we have our Discord. You guys can always reach out to me on there. I'm, like I said, the Explore PM, so you guys can just at me. I think my name has something to do with Tetris, but you'll probably be able to find me. Okay, so if you guys are done with this, again, you'll have an opportunity to fill this out at the intro workshops in these coming weeks. But this is the most important thing that I'm going to talk about today. So first things first, if you guys already filled this out for another track, then you don't have to refill it out. Just make sure that when you fill it out, you put both tracks that you're participating in. But I need you guys to fill this out right now if you haven't already, because this is what's going to help us get your feedback and be able to kind of use that to improve the program, make sure that you guys are getting what you need out of it, and see how we can take steps to make it even better for you. So everyone take a few minutes to fill this out right now. And I'm going to tell you again, if you don't fill this out, you are not getting your pins. I don't care. I mean like that. You need to fill this out because, again, we're trying to help you guys with this. It'll take just a few minutes. So I'll give you guys a sec for that, and then I'll move on to upcoming announcements really quick. I'm nervous about the time a little bit. I'm trying to go quick.
No worry. Try to go quick with the first project.
I put like worst case estimates for everything. Yeah. Yeah, it was like 75 minutes or some shit. So
it's fine. You'll do well.
I think it'll be fine. Just remember to, if you're not, because you have not the code, so just upload it before the previous one. Oh, and another quick note, if you guys did already fill it out for another track, but you have particular feedback for hardware that doesn't apply to the other one, please reach out to me, or if you really want to, you can go ahead and refill that out, and I'll kind of consolidate both of those answers. But we'd love to hear your feedback. We'd love to know how the program is going and if it's giving you guys what you need. So while you guys are finishing that up, I'm going to move on to announcements just so you guys can go ahead and get started. So I want to highlight our REACH program. So our REACH program is really good because once you guys are kind of done with Explore, you can move on to getting ready for those interviews and for those internships. So they offer career readiness workshops and also technical interview prep workshops. They're like alternating Thursdays and Fridays, so keep an eye out for that. If you guys have these projects under your belt, this is going to help you guys market them and go towards those dream opportunities that you guys want. So then I'm going to highlight a few events that we have. And again, these you can find on the Discord, you can find on our Instagram, everywhere, but just so you have in mind. Tomorrow we have our first web dev workshop for this second cohort. It's going to be at 3 p.m. in VH 131. You guys are going to be downloading all your tools, learning about the new project that you're going to be doing. So if you're interested in that, go ahead and join so you guys can kind of test the waters. On Wednesday, we have something super, super exciting and super exclusive. So exclusive that I can't even tell you guys what it is. But we're launching a brand new program, a brand new event that we're going to be doing with everyone. It's beginner friendly, particularly if you're interested in cybersecurity. This is something you guys don't want to miss. It's going to be Wednesday, March 5th at 3 p.m. in PG5 134. So definitely go and check it out. And that's all I'm allowed to say for now, or else I will get murdered. So. Then we have our AWS event on Thursday, March 6th at 3:30 in CP 151. I believe we have an alum coming in who works at with like AWS, and they're going to be helping you set up, I think, some cloud things. I probably should have gotten someone else to. They're building a VPN. Yay! Yeah, so definitely go check that out. Again, it's a great opportunity to network, get some projects, get some skills in that you otherwise might not be exposed to. So yeah, I'm gonna hand it off to Mr. Franco now.
Thank you. Let's see. Okay, so welcome everyone back to this final workshop of this cohort series. I'm very happy that you guys came today. It's a very important day. We're gonna be going over the last topic of Arduino really quick, like to get familiar with it, but it's gonna be very, very essential for the final project that we're gonna do, which is the one that I want to spend the most of the time. And it's gonna be really, really fun. And actually, I have here, after, when we start the final project, I'm gonna give away one giant Uno, right? Not an Arduino, just an Uno.
Woo!
But it's gonna be for the first one that finishes the final project. So please guys, follow all the topics that we're gonna do. So, did everyone check in? Correct? Everyone checked in? Yeah? Okay, great. So, quickly for the agenda, so the announcements, ready? So we're gonna be covering the last topic of this Arduino, one of these Arduino concepts, the analog input. Very important. We're gonna cover the ultrasonic sensor, which is the one that we're gonna be using in the final project in some minutes. And we're gonna jump quickly into the projects. So let's start with the analog input. I don't know if you guys remember. Let's see if anyone can answer it. Do you guys remember the digital input? What function did we use in the Arduino IDE to read digital input? Yep.
Digital read.
Great. What values does it return?
So from 0 to 255.
From 0 to 250. No, actually no.
Oh,
What
I
was
don't
it?
know. I don't know. I was thinking of the PWM.
Digital read. What were the possible values? Where to? Important. You remember?
0 and 1.
0 and 1, exactly. So if you guys remember from the past workshop, when we were dealing with the button, then when we pressed over it and it returned like a 1, and if you don't press it, it returned a 0. So it's gonna be pretty similar, but in this case, it's not gonna be discrete variables like 0 or 1. It's gonna be within a range of 0 and 1023. That's how Arduino works and how it works internally. I think there is someone that wants to enter. Okay, so in this case it's going to be within 0 and 1023. That's how Arduino interprets the analog values, and that's what you're gonna see in the serial communication when you debug your application. And again, in terms of electricity, the same as with analog write, when we wanted to change the brightness of an LED, that you pass a value from 0 to 255. The same way, it's going to be between 0 and 5 volts. It's the same way, but just in this case, as an input, we're going to be, instead of 0 and 255, it's going to be 0 and 1023. And as you can see in this image, in your Arduino board, so Do you guys remember what were the digital pins? What numbers that we used in the board? 10 to 13. There are more, but yeah, those are digital. Well, it's actually the entire row, right? So from 0 to 13, but we use from 2 to 13 because 0 and 1 are built in for other things like communication protocols that we're not going to see this time. But those are very important as well if you want to use, for example, Bluetooth or Wi-Fi, GPS, which in robotics is very, very important. So moving on with this topic. So actually, we're going to jump into the first project real quick. So I want you guys to grab your kits, grab your breadboard, your Arduino Uno, as always, and start wiring this. We're gonna go real quick in this one. And as always, make sure that with the LED, grab 1, 2, and 20 ohms resistor. That's very important. And that's gonna be for the shorter leg of the LED. And make sure you connect the ground pin to the shorter one.
Yeah.
Hello, darkness, my friend. I've come to talk with you again. With a vision so clear to me.
Will this lecture be posted somewhere?
Yeah. So in our Explore Hub, you'll have both the PowerPoints and the YouTube.
Okay.
Yeah.
Explore Hub.
Yeah. Go.fiu.edu/Explore Hub, and then our YouTube channel is just in it FIU. Yeah. In the vision. make it. But
Oh, with that? Oh, that's not my, that's not me.
What's going on? like question on the it's one on the left. want you guys to open the Arduino IDE and start. Actually, not. Let me see. This code. So you can start typing this code. There you go. So you can start typing it, and then we compile it, we upload it to the Arduino, and we see what's going on.
Bro.
It's really chill. I like how it's like a super slow. Like it's just all colors. Yeah, yeah. You could just walk from the town down. Did you take the Gator Right, no, but the Gator shuttle runs like all night. Yeah, it's not fire. You can get straight in and see that shuttle. It's actually fire. Oh, what was the country?
Nicole, could you watch my stuff? I'm gonna get my lunch. I'm really hungry. Yeah. No. Just like make sure nothing falls. Yeah.
Did you guys finish with the code? No? Yes? Not yet?
That's where you
Okay, so one more minute and we see what's going on. So don't worry if you upload it and the LED doesn't turn on because it's not supposed to, at least for this one. We're just gonna see what's going on with the analog input. Okay, so everyone please upload the code to your Arduino, connect it to your laptops, and then as always click this little arrow pointing to the right. Let me know if it runs any error, but it shouldn't, honestly. Did everyone upload it? Yep. Okay. So now if you open the serial monitor, the same thing that we used in the previous workshop to debug what's going on with the input. Remember that it's very important to see before, when you run into some problems, to see if it's actually reading it, if there is a hardware error, software error, so it's very useful. So you open up the serial monitor with this little icon. It should open right here below. And if everything is working, you should see like a whole bunch of values printing out. Is it working? Let me know. Yep. Great. Did it work, guys? The potentiometer is working? Yeah? Oh. On the right here? No? What's going on? Error message? What? 302? Oh, maybe the serial port.
It's a line here.
Where?
That's the arrow.
Oh, why the line? Compilation. It's the same code, right?
Yeah.
Delay. Yeah, should work. Delay. Loop setup.
What did it say? What was the...
Wait. Go up. A little. input, remember, it's going to be 123. Sorry, 1023, yeah. And we're going to use the built-in function the same way that we did with digital read. We're going to use analog read. And we're going to send the first argument is going to be what? Our pin for the potentiometer, A0, right, which is storing the variable. Then we're going to get, again, a value from 0 to 1023. And what we want for the future, you're going to see why it makes sense to scale the value. Do you guys remember what values we had to pass to the analog write in order to change the brightness of an LED? What is the range? Who? Exactly. Great. Thank you. From 0 to 255. So you're going to see in the next project that we're going to do quickly because the circuit is going to be the same. That's why I asked you to do it in advance for the LED. And it's basically printing out to the monitor, which is a good practice, right, to see what's going on. And now, so for the next project, wait. So now, for the project that involves this, what you just did, so we're going to use those scale values, which you can read the previous code that we did, to turn on actually the LED. So you're going to change the brightness of the LED dynamically with the spinning thing, the potentiometer. So try to do that, and in, let's say, 10 minutes, we try to implement it. Want to download the file? I just uploaded it to the Explore Hub in go.fiu.edu/init. So it should be there as well if you want to download it and open it. But if you want, you see it from here. Yep. So as you can see here, what we are doing is basically taking the material from the previous one. We are using the scale value, which we did it on purpose to do it between 0 and 255. Remember that those are the values that we should pass to the analog right to pass like a certain voltage. In this case, 255 is going to be the highest brightness, and the 0 is going to be like turned off. So in that way, when you spin it, the potentiometer values are going to change, and therefore the brightness should do as well. So try it, and we move on to the final project. Yep. Okay.
I got it, but it's not working.
The LED pin, scale value. Okay, it looks, I mean, the code looks fine.
Yeah, right. Is the rubber work fine? Or?
Let's see this. Okay, so you're using, so ground there, connected to left. Okay, so, oh. Wrong way. Yeah, remember that the long leg is for the positive side, and the short one for the ground. Guys, make sure the LED, the pin is connected to the largest leg, and the ground is connected to the shortest. Yep, we can do it like after, like in 2 minutes. Yep. Like before the final project you want? Yep. Or after?
Probably before.
Before? Okay. Great. Okay. So could everyone compile this code? Everyone could make it work? Like change the brightness with this new code? Yep. Great. Over there? Yep. There? Okay. Great. Could you guys hear? Wire potentiometer, okay. You're reading it, you're scanning it.
Yeah, again, if you're.
That looks good, unlock right. So you compiled this code?
This?
The arrow.
This?
The other one, that one, upload. So whenever. I hope it worked. Oh, no, I know. Let me see. Oh, wait. So, did it work, actually? Yeah? Great. Here, okay. Over there, I see work. Guys over there, work? Okay. So, we're ready to move on to the final project. So, it's gonna be, oh, let me see, it's not showing the screen that I want. So now we're gonna get started with the last project. So this is a fancy one. It's the Ultrasonic Composer. So basically we're gonna be creating music from sound waves that we're gonna see in some minutes. So I want you guys to start looking for this sensor, this component that you should find in your kits. So as you can see here, we have the 5V that is gonna be connected to the VCC pin of the sensor, right? So we're gonna have 2 pins that we are gonna be connected that I'm gonna show later how it is connected to the Arduino board. And then as always, we will have a ground. But the way that the ultrasonic sensor works, so we have 2 circles. One is the transmitter and one is the receiver. The transmitter is sending very, very tiny small waves to the object that is gonna, because this sensor first is gonna, this is important, is gonna measure distance. How is it gonna do? How is it gonna do it? So it sends ultrasonic waves to the object that you want to, measure the distance to. Then that object bounces back that sound, and the receiver is in charge of actually, of course, receiving the wave, the sound wave. So what Arduino is doing internally that we are gonna see in some minutes in the code. So we're gonna be using one function that is basically gonna, it's gonna calculate the time that it took for the sensor to retrieve that object back, the distance, and we know the speed of sound, right? The formula that you guys are gonna find to do the final project, we're gonna have, as a result, the distance. So that's a very common sensor that is used in robotics, the ultrasonic one. But again, it has also some drawbacks because the object might bounce the sound not in a very good way for the sensor to receive it. So there are some other sensors that are used, like lidars and other more effective sensors, but for this project it's really good. So basically that's what we're gonna need, at least mainly. So this looks kind of confusing, but you're gonna use just one Arduino and one breadboard because I couldn't find a diagram that fits both. So you're gonna find that little black circle that is called the passive buzzer. That's going to be in charge of emitting sounds with frequency that you're going to put in the code. So it's going to be already built in by me, but you're going to call a function you're going to see now. So make sure you wire this in a proper way. I know there are a lot of connections here. And what you have to do here, which is important, let me see. So make sure the LEDs, because the diagram below, they are connected to 3 and 5 pins. But I want you guys to connect the red pin, the red LED, because I don't want you guys to find like 2 red. I want you guys to find 1 red and 1 green if you have it. Let me know if you don't have it, 1 green. But for the red LED, we're going to be using pin 10 that I'm going to show now in the code so you don't get confused. And for the green LED, we're going to be using pin 11. So that's very important. So everything else, you can keep it as it is. And what is important, the ground here. So you're going to be connected. So you don't have to remove the ground, the main ground that is connected to the row of the breadboard, right? And you can feed the passive buzzer, the little tiny thing there, the black thing, with the same way that you're doing it with the LED right now. So you can just, use a wire to connect it to the left side of the passive buzzer. You can see there's a little icon that it has, which is a positive. And make sure, because there are 2 that look the same, but make sure you grab the one that both legs are the same length. the ultrasonic sensor, and the 2 LEDs. Start coding it, but I'm gonna show first what the code looks like. So this entire backbone of the code, right, it's kind of large. You're gonna see that there are also some functions that I already wrote for you guys, but for the main function, you're gonna be doing, as always, the to-do part, right? So you can see that we are calling the same. The variables on the top, the pins that we're gonna use, the variables that are gonna change. In this case, we have duration, distance in centimeters, and distance in inches. And this now, you can ignore it. Also for the pin mode, so you can see that we have 3 pin modes, one for the LED as always. Actually, I see that I'm missing one pin mode that you should add it to the red LED and green LED. And then there are 2 more pin modes. One is calling for output that is calling the trig pin, which, as you can see before, here we have a trig and echo pins of the sensor. Remember that the trig is gonna be the transmitter and the echo is gonna be receiving that sound wave. And basically we're gonna be saying to the sensor is, okay, so the trig pin is gonna be emitting the sound wave, is gonna be an output, and the echo pin is gonna receive the sound wave, is gonna be input. So, and then for the part of the loop, so there you have code like digital write, delay microseconds, that's the code to read the sound, right? And then I store it for you in duration in microseconds. That's what pulls in, which is built in Arduino, what it returns. And if you find a distance that you have to Google it, right? You just need to translate the duration in microseconds, and following the speed of sound formula, you should calculate it in centimeters and then also in inches and print it out to the console. That's the first part. But before moving on, you can still wiring everything and I can help you out. Let's see. And if you go to the Explore Hub, what I said about the connection, the pins that you need to change from the diagram is noted there, is written. Oosh. Okay.
How do we get the code?
It's in the, so have you ever opened the Explore Hub before?
No.
No, okay. So go to go.fiu.edu. I mean, sorry, go.fiu.edu/init. Okay, open it. So open the Build-Your-Own Mini robot.
even gone to the code yet, have you?
Yeah, I did, but
Oh, okay. That's fine. Alright, guess not. Nobody needs my help.
I don't know. I think they need they need help with the connection.
Who? You guys?
Ten. Hey, how are you? Yeah, feel free.
It's just building a robot.
Like we are in the now doing the final project. And that is like it's gonna trigger the Harry Potter theme, like with the ultrasonic sensor and magically, kind of try to recreate it. But yeah, if you want, you can join. Don't worry. No, don't worry. Let me know if you need help. So let me see. So just.
So I'm gonna compile it.
Okay. Does anyone else need help? If you do, raise your hand.
Yeah, locked it.
I guess we're fine. You know what might be helpful? If you, for next time, you try to like find a diagram maker, like a circuit diagram maker, so you can have
Yeah.
everything together.
I try, but it's so
Yeah, the pieces are all different.
different.
Yeah, I figured.
But I'll try for the next.
Just because, like, for me, it gets confusing when they're in two separate pictures as well.
No, yeah. I know.
Tinkercad is good for that.
Hmm?
Tinkercad is good for that.
Tinkercad? Thank you. Yeah.
No, it's not for
Pretend.
for something else.
That's tough. Pretend.
No, just whatever you would say.
What do you want me to? What's the
Like if
pose?
you're- Like if you're teaching. Don't worry about it. Not like that. No, not.
How do you
like
want me?
Just talking.
Wait, but when I talk,
Just talk.
I have to talk? So how is it going, the wiring part? Good? Yes. Now you say yes.
What's an Arduino?
What's an Arduino? An electronic board, open source, that allows you to play with.
Could you look at like
Oh, you are actually recording?
no, it's not. Just pretend like you're talking.
An action shot, okay. So, wait, let me open the code and I can do it for real.
Okay, yeah, I'll just wait till you do.
Yes, that's better.
Okay, and when you're talking, try to like talk, like look at someone, look at like horizontal.
At some point? At Jorge.
Yeah, you can look at him.
Okay,
It's just that when you're looking at the computer, it just makes your forehead look a little dark.
okay,
It just doesn't look good.
okay. Wait. Hi, thank you. Okay. Uy, 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 uy. So guys, in the part of the, if this doesn't scream, wait. So in the part of the to do, like you can see that there are like three main like tasks. So the goal is if the distance that you're gonna measure is less than 20, it's gonna start like, you know, triggering the Harry Potter theme that you guys now gonna see in some minutes probably. So I tried to put a lot of hints for you to use in the, mainly with the functions that are written on the right. Then if the distance is between 80 and 20 centimeters that you should have calculated previously, then what you're going to do is first increase the green LED brightness as it gets closer to 20. So in this way, it's kind of, you're telling the robot that it's getting closer to trigger the sound for you to know that it's going to trigger. So that's a kind of visual guidance for the user, which is very, very important in robotics. What else? So you're going to be using the map function. That is something that we used throughout the entire cohort. So we want to convert the distance, in this case, from 80 to 20, as it gets closer to 20, we want to pass it like to full brightness to the green LED. So the equivalence would be 20 centimeters is going to be passing 255, and on the other hand, 80, which is the furthest distance, is going to be 0. So in that way, as you approach a hand to 20 from 80 centimeters, you should see that the green LED gets brighter. So that's the first thing. Then, so you're going to be using the analog right to change the brightness, as we saw before. And then if the distance is less than or equal to 20 centimeters, then is when you're going to trigger the Harry Potter theme, which you should call make magic happen function. And again, you need to do also, in addition to the sound, so you need to turn on the green LED at its like fullest brightness, which in that case, as you just want the brightest thing, you want full 5 volts, you can use the digital right, which is also another function that we saw before. And also I want you guys to turn off the red LED, which is telling you, okay, it's not even close to 20 centimeters, right? So while it's not 20, it's going to be turned on, basically, the red LED. So, yep. So in that way, so make sure that the ultrasonic sensor is pointing kind of to the palm of your hand. So it's going to bounce like better, and it's going to be more accurate. And actually, I'm going to show you, just in case if you couldn't. So I'm going to show the code for you to do, because we should start wrapping up soon. Let's see. So first, remember the red LED here. Let me do some zoom in. So we define the red LED pin to 10, green LED pin to 11. Make sure that in your board it matches this code. And then for the trig pin of the ultrasonic sensor, make sure you connect the trig part to the 6 and the echo to 7, respectively. And the buzzer, so you see the right leg, so I see here close. In the buzzer, make sure you connect it to the pin 3, that's important. And then, actually that I forgot, that is a problem on my end. So you saw that it was here float, duration, so it shouldn't be duration, it's duration in microseconds. So make sure to change that in the code. The same, you can keep it. And also, very important, make sure to add these 2 lines of code besides the trig and the echo pins. So those are for the red and green LED pins. So this we already saw. So here we are calculating the distance in centimeters. You can start typing this code if you couldn't type it. If you couldn't make it. But yeah, this is basically converting the distance in microseconds to the duration of microseconds, taking the speed of some formula, and it's explained in this line, right? So then it's just, we have the distance in centimeters, 1 centimeter equals 0. Almost approximately 40. So this will give you the distance in inches, which you're going to have to print it out in this part of the code, right? So this is just for debugging purposes, for you to see. And then where the magic happens is in these 3 if, else if, and else statements. So here, if the distance is greater than 80 centimeters, turn on the red LED, but turn off the green LED. So we are saying if distance is greater than 80, digital right. Remember that here we just want to high or low. We are not interested in brightness here, just turn on or turn off. So we are turning on the red one. We are turning off the green, saying, okay, you are very, very far from 20 centimeters and even greater than 80. And then once your hand or whatever object you want to use approaches 20 centimeters from 80, it's going to go into this else if statement. It's going to go in. So we are saying it's a biconditional. So we're saying if the distance in centimeters is greater than 20, so we are not, it's greater than 20, but the distance is also less than or equal than 80, so we want a way to say to the user, okay, you're getting close to the song, start turning on as it approaches to 80 the green LED, but turn on the red LED because it's saying, okay, the song is not like playing. Right? So that's what the red LED is saying, basically if the song is playing or not. So we want to keep it on. So if the distance, finally, is less than or equal to 20 centimeters, which you're going to see that if you debug it, if you approach it like very close to the sensor, it's not going to read very good the values. That's because of the sound wave effect. So we're saying digital right. So please turn off the red LED. Just turn it off. Turn it on, the red LED at its highest brightness. So we just want it to be high. And then we call make magic happen, which should start playing the Harry Potter theme in the buzzer, which is a little black tiny thing. So if you follow this code, it should start playing it. Remember what I said about these variables and to define the pin modes in the setup for both LED pins. So I'm going to upload it in the Explore Hub. I think it's better. So you can guys have it and just copy and paste it if you want. There you go. I think now it's published. You can check. I want to see who can start playing Harry Potter, the first one.
And you get your Uno.
And get your Uno, your giant Uno.
Giant Uno.
Giant Uno, yeah. To the mic? Okay. Yep.
For the one, like the song.
Yeah. Do you want me to play it, to do it?
No, when you finish.
Where is it?
Oh,
You're doing it?
Close.
who has it?
No, but she's saying if you can maybe you should put your
Get closer to
connection on
the-
the thing on a little microscope
Okay.
so they can see the connection, and then you put the mic up to the.
Yeah.
So, wait.
I know it's annoying for you to.
No, it's fine, but I just want to make sure that...
So okay, I think she's saying you grab this,
Oh, and put this.
and then maybe we can take this out.
Yeah, the thing is, it's going to start, you know...
Yeah.
They got it. They got it? You got it? Yes.
Nice.
Nice.
So cute.
Wait, so...
Oh, you can show like the thing on the screen.
Mm-hmm.
Oh.
That's what I've been trying to do.
Because it's kind of, you know...
Yeah, I get you. Alright, we'll put that there. Oh, sorry. Okay. Oh god.
Oh my god. This is...
Yeah. And then I guess just rerun the code so that it starts from the
I
beginning.
Should I keep this?
We'll put this
Oh,
here.
okay, here. Okay.
But should we rerun it so it starts from the beginning?
Okay, so you want me to rerun it?
Yeah.
Let me see. Oh, wait.
Where's your Arduino ID?
So, Resolve.
Oh, it's yours. It's so cute.
We upload it. You ready? For the video? Okay. Now it's kind of approaching. This is far away, so it should be. I took so much. And that's it. Cute. And then it starts like. Kill it, yeah.
Who had gotten it first?
I thi-
Then you get giant Uno.
And then you get a giant Uno.
You want it?
Let's get a round of applause for her. Nice. Congrats. Great, so
Mine has an error. He only goes to when I'm.
I don't know. I think I have the. Well, this is your code, but this is mine. I think there might be a mistake in the wiring. I don't know if you can.
in where?
In the wiring.
In the light?
Sí, lo revisamos con Nicole, estaba todo bien. No sé,
What is not working? Like what? The LED?
no, the sound.
Not the buzzer?
The sound.
Really? How you're connecting it?
This should go like in 3 or in 2?
Wait. The thing is, make sure you're
The same.
the same column.
Intenta hallar. Así debería funcionar.